can. Come on. Come on. Let's see. Figure the video. Nope, that's not gonna do it. No. Come on. Just detect it. No, it doesn't want to go for it. Oh well. There you go. I'll try and sort that out later. Okay. All right. I'm not really sure what to ask. I think after the lecture I'll have a mess about the Maya and see what I can do. Yeah, that's the best. That's the best thing. Didn't you guys used to chant maple syrup to get me to show up or something like that? Yeah, that's right. Okay. So let's talk about something a little bit kind of more specific. You know what? I'm probably going to get rid of this guy. I'm going to talk about a few sort of concepts within the joints themselves. Right? If you made emotes, dare I ask? I don't know. Okay, so let's talk a little bit about joints and transforms. I think it's really kind of important. Again, I'm about to dive into technical stuff. You guys may want to take notes. This is info that you might find kind of, why do we need to know this stuff? But then later on, like years from now, you'll be animating at midnight and your rig is going to blow apart and you'll be like, why didn't I take notes? Yeah, Maya is quite complex. I think once you get your head around navigating and object space and global space, it'll become a little bit easier, right? So let's first take a look. Actually, I'm going to create just a new joint. Oh, right. And I'm going to snap it there so it's in the same vicinity. Right? Okay, so one of the things I'm going to talk about is, first of all, let's get this joint to display larger so we can talk about it, etc., etc. And along the way, I might mention stuff that I'll clarify. Right? So we can do one of two things. We can scale it up. Oh, they don't allow you to do that anymore. And there's a reason why. Because I was going to say, no, you don't want to scale it up, right? What you want to do is you want to increase the size of it in the display, but not actually affect how it works on your character inside of Maya. Right? So how do we do this? Well, every object that you create inside of Maya, if you go to the attribute editor, down at the very bottom of the attribute editor, in these menu sets you will never open, or very rarely open. I have never opened these, right? These are minor controls that allow you to adjust how you can interact with Maya to just make life easier. So let's just say, you know what, I want to keep the joint the same size. I don't want to add data to the joint. I don't want to do crazy scaling, whatever. I just want it to look bigger, right? So you can do that in here with the joint itself. I'm going to go down to display, right? And I can, under drawing overrides, I think is it in here? Where's the, I thought it was here. All right. I might be looking in the wrong spot. I'm looking for a subcategory called locator scale. Is it in the extra? I don't think they would have taken it out. So what was that? Locator scale, locator scale, locator scale. Oh, I cannot find it in here. So enable the overrides. Okay, I cannot find it. But the drawing overrides is an important area to take a look at in terms of how you want to change how Maya displays stuff, right? So at the very least, what we can do is we can grab this joint and say, look, I want to enable a drawing override. I don't want you to show me what default Maya will show me. I want to change the color of this to, I don't know, something bright so I can see it, right? Right. So it hasn't really affected how the joint calculates. It just shows it to you a little bit better. Okay? So let's zoom in on this guy. I'm going to select my camera. Now it looks like it's vanished, but it hasn't. Right? It just means that my near plane and far camera clipping plane needs to be set. And it'll take 2 seconds to explain that. So every 3D camera has what's called a near clip plane and a far clip plane, where anything close to the camera, it'll just, beyond that near clip plane, it won't draw. And anything beyond that far clip plane, it won't draw. Now, this exists for a reason. If we did not have the clipping planes in front of the camera, Maya would just draw everything out to infinity, right? Now, you can imagine how that would affect render time if you had this huge, massive environment. So clipping planes are there to sort of restrict, whenever you cast a ray to calculate a distance, it just restricts it. It says, just stay inside this visible box. And so I've just pushed my near clip plane a little bit closer to myself, so now I can see that joint. That's all that is. So anytime you have a situation, and you will, this was the most common error for me when I first jumped into Maya, where objects completely vanish on you, 9 times out of 10, it's the clipping planes on the camera itself, right? Which you can access here in the shape node for my perspective camera under near clip plane, far clip plane. And when you get in there, it should already be open for you, so you can just find it super quick. Okay, now let's talk about the transform matrix, right? Because that's important, right? Now the transform matrix is oftentimes referred to as an SRT, scale, rotate, translate. And that's kind of good. It was used quite a bit in the industry for decades. You know, watch your SRTs, or what are your SRTs or your transforms? Okay? Well, scale, rotate, translate, and it's called SRT for a reason, because that's the order of calculation of the mathematics, right? Scale being the predominant factor, right? Scale affects everything later on down the chain, right? So scale affects rotation, scale affects translates. So that's something I'm going to come back to. But with scaling, you have to be very careful with scale, because scale is a multiplier. What does that mean? That means it will have unexpected results later on down the line from your rotations and your translates, unless you plan incredibly carefully. Translates are additive. You want to translate it 2, you translate it by 2, right? Multipliers are not predictable, right? So if you have 2, and you multiply by another 2, boom, it'll jump over to 4, right? So that, I'm being pedantic, but hopefully that helps you to understand why scaling can oftentimes be dangerous. It will make your values jump all over the place in unexpected ways, especially when you're in the deep throes of putting together like a 100 joint chain system for a camera. And it harkens back to a rule that I gave my regular group at the beginning of the year: never scale joints. And we'll talk a little bit about that. But let's talk about rotation, because rotation is the biggest problem inside of any 3D software, right? So let's take a look at rotations, right? So let's say I want to rotate this joint, right? So I move it like this, I move it like this. Now you can see that the rotation gizmo follows that, right? This is because the rotation is set to local orientation, meaning it's going to follow the rotation of the object, right? That's local rotation, right? Now, if I were to come in here, I'm going to hold the E key and hold the left mouse button and switch to world, right? The rotation matrix will stay oriented to the world. Now, can you guys see a problem with this, though? What's the problem with this? There's a huge issue with this. Everyone's typing. Hey, everyone's falling asleep. Am I still broadcasting? Live and in your face? Ah, okay. Okay, all right. So, Julia and Tyrone are typing. That's cool. Oh, cam died. Oh, okay, okay. My camera? Did my camera die? Or yours? Ah, man. Okay. Can you guys see the Maya screen now? Okay, cool. So this will be the best way to summarize what the problem is, right? Is that joint at a 45-degree angle or a 90-degree angle? What rotation is it at? Roundabout roughly, how is it oriented? You can't tell because the rotation gizmo hasn't changed. It's still oriented to the world. If I were to hold down the E key and left click, switch back to object, then you can give me a guess. You can say, oh, it's rotated, it's 45 degrees along the Y, and et cetera, et cetera. It's easier for you to predict, right? So that's the difference between world coordinate and object coordinate, right? Now, in the beginning, when you're, doing your modeling, you may switch between the two. Let's go back to translate. Let's say you want to line objects up together. My transform gizmo is set to world coordinates, right? But you can also say, you know what, I want to hold down the W key and the left mouse button, switch to object, right? Because you might want to move it according to how the object moves, and it becomes easier to line things up and stuff like that. So you'll find yourself switching back and forth from object to world and then to object again. Sometimes you might want to switch it to world because you want to know exactly, you might want the angle of the object not to change, but you want to move it carefully to a specific location. So you'll find yourself jumping between two different systems, right? Let's go back to rotation. Now, here's the thing though, right? The world rotation matrix is lying to you. Object rotation matrix is lying to you. They're not telling you the true rotation of this object, right? They're just being friendly. They're just being nice to you. They are showing you or telling you what you want to hear. These are designed to make it easy to work with rotations inside of 3D Studio, inside of Maya, right? Makes it easier to work with rotations. They are lies. They are definite lies. If you want to know the truth as to how your object is being rotated, hold the E key, left mouse button, right? And go to this thing called Gimbal. Gimbal will show you exactly what Maya is calculating behind the scenes for rotation, right? Now, here's the reason why Maya lies to you, right? Look at what is happening with the axes as I rotate, right? You see what's happening? Not all of them are moving. Some of them are moving quite unpredictably, right? I'm lining up two axes here. What if I want to rotate like this way, right? I can't. I got no axes. I can't rotate it through here. It's impossible. Why is it doing that? It is doing that because our system of mathematics that have been developed for centuries is flawed. It's flawed. We need to reinvent mathematics. The way mathematics has developed is incorrect. How the world works. I'll show you. And this might help you understand too. So let me pop up in Photoshop so I can draw this. We do need to reinvent maths. We absolutely do. We have to take centuries of mathematical knowledge and chuck a large portion of it. It's actually not even maths. Our whole system of numbers is flawed. It goes right back to just how we count. This blows minds when I mention this. Yeah, let me show you. Okay, so when we started developing a system of counting, right? 1, 2, 3. Our 10-digit. Do you know why we have 10 numbers? Oh, it should be pretty easy. It's going to be 10 fingers, right? So we have a system of counting, and then we raided the Arab countries and stole their zero, right? So we came up with this concept of numbers, right? And that's the foundation, obviously, of all mathematics, right? But there was no way of tracking anything other than by going forward, right? So then we came up with a system of negative numbers, right? Yeah, you guys know this. Blah, 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 right? Here's the problem, right? Here's an essential problem. We know where 3 is, located on the number line, right? We know where negative 3 is, located on the number line, right? Where is that number 3 in space? Where is it here? Where is it here? Where is it? Some of you might go, oh, it is 1, 2, 3, right? But which 3 is it? That one or that one? Right? If I tell you, oh, if you say, where do I go, Al? Oh, yeah, easy. Just go to that coordinate number 3. Right? You don't know. Because our whole system of counting is developed based on linear thinking. Right? Never really took into account that we may want to rotate. Right? Hence, imaginary numbers or compound numbers. Oh, no, complex numbers, right? Sometimes referred to as imaginary. So have you guys heard of imaginary numbers? I remember learning imaginary numbers when I was in high school. I'm like, what? And I just got completely lost. Yeah, letters are involved and labeling, but how do you calculate letters, right? So I can say 3 and 3i, or 3y, because it's up on the y-axis, right? So yeah, okay, 3 plus 3, right? So then you start to see how algebra develops, right? To kind of help hack this, or patch it. So we're working on a linear system, going in one direction, and we're continually modifying it to help us work in 3-dimensional space. So what does this all kind of have to do with rotations, right? Because there are limitations in terms of how we calculate sort of distances using linear values, right? Rotational mechanics have always been a bit of a problem, right? So enter a mathematician named Euclid, and he developed a system of rotational mechanics that we call Euler rotations, EULA. Right? So Euler rotations is at the heart of how we rotate objects inside of Maya. Unfortunately, with Euler rotations, there is a dependency in the mathematics. So you have to calculate one axis first. You cannot calculate the next axis unless you use the original axis value, and so on and so forth. So there's this dependency, right? So there will always be one axis dependent upon another. Meaning that when you get to a certain point, you will run out of axes to rotate. And again, it all has to deal with limitations of calculating things using an archaic method of very linear method rather of mathematics. And I'm super simplifying. I know that on the Twitch stream there are mathematicians out there going, "What? You're an idiot!" But it's getting to the heart of helping you to understand why these conditions exist. So some of you guys might go, "Well, yeah, no problem. I'll just sit there and I'll switch over to object mode. There you go. There's my axis. See, what's Al talking about? I can rotate it. No problem, right?" Here's the thing, right? You can switch to local axis, rotate it, right? Fine. You've got your keyframe at one point, a keyframe at another point. That's not what Maya's doing in the background. Maya in the background is saying, okay, I've run out of an axis, and Al switched to object mode and asked me to rotate through here, but I can't. So I'll do it this way. I'll rotate a bit here, a bit there, a bit here, a bit there, a bit here, a bit there, a bit here, a bit there. And then this is what it's doing in the background to get to that rotation. And then it's rotating. This leads, and I'm super simplifying, but this leads to a condition called gimbal lock. So gimbal lock happens on a very practical level when a character animator says, I want to rotate this guy's arm this way to there. So you set a keyframe here, and you set a keyframe over here. Cool. Now let's hit play. And you're like, what happened? What happened to my animation? Then you set another keyframe here, and then it's turning the wrist there, and then you play, and it goes, and you're like, what? Right? So that gimbal lock situation happens because Maya's trying to figure out how to get to that position with a limited number of axes available to you. Right? That is Euler rotation. Right? So this is Euler rotations based on Euclidean geometry. Right? Now, there is another way of calculating rotations that is a little bit nicer. Actually, I will have to Photoshop this. Back in the Photoshop. I shouldn't have closed it. And we'll talk a little bit about that. Right? So this is again, I warned you guys it's going to be technical and theory, and you guys don't really need to know this to get in an animated character, but yes, you kind of will, because when you run into trouble in production later on down the line, you'll be thankful that you paid attention. Doesn't it rotate the whole axis of the object by a set of 3? How do you mean? Rotate the whole, are you talking about it rotating the whole, like, are we rotating the y-axis by a set of 3? By the way, gimbal lock affects everybody, right? So airplane, pilots, right? Pilots run into this front center all the time. They have to be very, very wary of it, right? Because the way their system of controls is developed is about around 3 concentric rings, and there is a point that you can hit, if you're not careful, that the plane itself will gimbal, right? So it's not just us, right? Set of 3 for each axis. Each axis has a single set value, right? So each axis, the x-axis has like 0 to 100, and the y-axis 0. The concept of gimbaling happens when you run out of a rotational axis in a calculation, and you have to get to a certain point in your rotation, so you cheat it by using the axes that are available to get you where you need to go. I don't know if I'm answering your question. Okay, so what if we take the center of the sphere, calculate to the surface of the sphere, and travel across the surface of the sphere to that point, right? After all, we can travel along the surface of the sphere however we want, right? It's just a distance calculation across the surface of the sphere. I'm super simple. Right? So this is a new way of dealing with rotations, and it's called, believe it or not, quaternion. When I first came across this word, I thought somebody had made it up. It's very Star Trek, right? Quaternion rotations, right? So quaternion rotations are rock solid. They're safe from gimbal lock. So which is better? Euler rotations or quaternion rotations? Which is better? Yeah, it does sound like a transformer. Quaternion. So quaternion rotations, because it's calculating, traveling along the surface of a sphere, right? It's really robust. You'll never get really any kind of gimbal lock situation with quaternion rotations. Which one's better? Well, when you calculate distance traveled along the surface, you're not really calculating rotation anymore, are you? You're calculating distance. So it's a little bit more robust, right? But it's a nice guess. Quaternion rotations, for all intents and purposes, is better. But the fault now lies with us. We're the stupid ones. That's why I wrote this. It's our fault. We're the stupid ones. I'll tell you why. Well, if I tell you, I want you to go into this character and rotate it by 4,562 degrees, please. 4,562 degrees. What is that? Or actually, let's try 4,560 degrees. Rotate that arm 4,560 degrees. No? Can you rotate it 180 for me? Ah, get it. Right? We're used to thinking from 0 to 360 degrees. Right? Which is how we deal with Euler rotations. When you deal with quaternion rotations, the values just don't make easy enough sense for us to be able to quickly digest. And again, I'm uber simplifying it, but it'll give you just a taste, just a flavor of the things that are involved when tackling rotational mechanics with a 3D character. And I probably lost. I'm going to wait for Tyrone to type his question. And whilst not doing that, I'll go to YouTube. Okay, so one of them, it's a 3D space where they should have applied a different theory of application instead. Yeah, pretty much. Yeah. Yeah. So we know how to rotate things in real life. I can just go rotate, right? And so the problem of us rotating, that's easy, right? But having a machine control that rotation is harder because that machine needs to be driven by mathematical calculation, and the system of mathematical calculation is flawed. So when an aircraft gimbals, it's not because rotations don't exist in the real world, it's that the pilot's controls in the airplane are using Euler rotations. And, referring to things in 0 to 360 degrees. Yeah, I'm not getting uber complicated with maths. In fact, I'm simplifying it like crazy. It's just the concept, right? I'm not expecting you guys to be able to spit out equations that involve imaginary numbers. I just want to try to kind of easily help you perceive what's going on in terms of animating, right? Now I'm trying to find. It's got to be there somewhere. I'll have one quick look. If I can't find it, I'll move on to something else. But it's just a really, really funny video based on this exact problem, right? Let me see if I can find it. No, I can't find it. Yeah, so the gimbal lock problem is a problem that hits animators all over the planet, right? So it's one of the biggest sort of issues in terms of, it's the concept of quantitative numbers. Yeah, it's pretty much, I'm going to close this now because you don't have to think about it now. I've given you the basics behind it. And the whole reason why I talk about this is because it will happen to you. You will be animating a character, setting keyframes, you'll hit play, and your character will be like, and then freak out, right? You'll be like, oh my God, what just happened, right? It will happen. Happens to all animators. It's like a rite of passage, right? So just be wary. That's what's going on in the background. Now, had happened to me before, so I've been looking into it. Yeah, gimbal lock. Oh, gimbal lock. I feel for you. Right? Now, how do we safeguard against gimbal lock? How do we prevent this thing from ever happening to us, right? By being incredibly careful and incredibly exact when you build your skeleton. That's it, right? No, not group up the geometry. When you are building your skeleton, you have to be incredibly precise. Oh yeah, I am kind of hitting you guys with this stuff at like a 9 to 11 course. We're almost at the end, so I better move it. You guys keep distracting me by having interesting conversations on Discord. Okay, so I'm going to run through this joint chain very carefully, and I'm going to describe some rules for you. Number one, the first rule, right, is that your root of your chain will have translate data on it because it needs to place that root in the world. So we need to know where in the world that is located. Every joint after that must have a clean matrix except for the x-axis. Right? 0 is all the way down, 1's all the way down, except the x-axis. Right? That's the first rule. Yep, come on in. Yeah, what's up, buddy? Yeah. Okay, let me talk to you in 5 minutes. Okay, because I'm just finishing up my class. Yes. Oh, the joy of V-Bucks. Okay, so the other thing we need to take a look at is the orientation of the joint. Now, nowadays, Maya does a lot of this automatically for you, right? But it's something that's, if you guys are aware of, you can check it if things go wrong with the rig, right? So this is not telling me the truth about how that joint is oriented, because remember, we are in world space. We want to switch to object space, right? The way your joint needs to be set up is with the x-axis pointed down the joint and the positive z-axis being the favored motion of that joint, right? So if I rotate my arm this way, it's positive. Or actually, yeah, no, let's do this. So if I rotate my arm this way, it's positive. But if I rotate my arm back, it feels uncomfortable. So that would be negative, right? So that's how you determine what is the positive z-axis rotation. It's like the preferred rotation 90% of the time, right? So the positive z-axis is our rotation, and the x-axis is pointed down the joint. Again, here, the x-axis is pointed down the joint. And it has to be mathematically accurately pointing down to the next joint. It can't deviate by even a small amount. Isn't all the objects upside down in Maya, so the translates are inverted? Upside down, do you mean pointing down the negative y-axis? No, that's not true, right? However, there are issues when you go into a negative quadrant, which I'll talk about later. I don't know how many times I've rigged a car with rotating wheels, and the minute I cross into a negative grid, the wheels start to backspin, right? There's a lot of issues, mathematically speaking, with the fact that we only have a number set from 0 to 10. Even the negative sign isn't entirely predictable. Okay, so all of our joints are clean. Now, this is important because it helps us with rotations and controlling rotations. It allows us to only ever rotate on the positive z-axis when we need to. Obviously, we'll have other axes that we'll rotate, but then we set the rotate order to what we prefer. So I can say, look, rotate on the z, that's fine. Rotate on the y, that's fine. I might go back and forth. Oh, actually, rotate on the x, that's fine, because I can twist my leg. But the last axis can be this, because you can't really rotate your leg that way, right, without breaking your kneecap. So you have to think a little bit. Which axes do you want first, second, and third? Right? You know, there will be points where it'll be debatable. There'll be areas where you've got multi-rotation. I can't really think of. Even the wrist, right? You've got up and down. Even when you torque it, you're not torquing your wrist. You're torquing your forearm, right? So it's just up and down, side to side. Even side to side is not that much. And then rotating this way, that's being handled by the forearm joint, right? So if you really think about it, you can work within Euler rotations. Why would you want to work inside of Euler rotations? Because thinking from 0 to 360 degrees is easier. I know where 90 degrees is. I know where 45 degrees is. I know that a lot of graphics programmers will have to switch from degrees to radians because radians produces cleaner math. But who's used to thinking in terms of radians? It's also quite complex, right? So, you know, working inside of Euler rotations is quite helpful. Right? So, the other thing is, the last thing to touch on is scaling. You must never, ever, let's say you go, okay, well, I've done this character, but I want to reuse the rig for a dwarf, right? So you might go, okay, let's scale that joint down. Right? Now you are multiplying everything in your transform matrix by 0.41. That will have all kinds of, can you change the size of rotation past 360? Oh yeah, no, you can go 720, you can go 1080. I'm just using that as an example, right? 360 isn't the limit. You can go, you know, however many degrees you want. It's just that we're used to thinking in terms of 0 to 360 degrees makes a complete circle, right? And we can cut that up, and it just makes more sense to us. But with scaling, that multiplier is going to have really undesired results. Aha! This is why riggers across the planet came up with this convention to have the x-axis point down the joint. The safest thing you can do is translate, because translates are additive. You can add and subtract, Nothing unpredictable there, right? So here is how we adjust the scale of a rig. We just translate that joint down the x-axis. Go over here, and I'll translate this down the x-axis, right? It's like scaling, but Notice how the rest of my data set is clean. Clean zeros, clean rotations, nice, everything's multiplied by 1, which just equals itself, right? We'll be able to make that dwarf rig no time flat, right? These are the basic sort of technical rules for character set, right? So if you're entertaining, you know, possibly a role out there in the industry, being a character setup artist or a character TD, these are the basics of building that skill set. Understanding how joints work, understanding the problems that you deal with rotations, right? Understanding the rules in terms of order of operations of having to do things. And if you want a character that gives you no problem in the future, my advice is to build your skeleton carefully, right? So any questions about that? That takes us right to 11 o'clock. I'm going to close down my, flip over to my Twitch stream and shut her down. See you later, Twitch.